Hey, this is the investigation that you were doing for homework last night on quadratics. And so for problem number 3, for review for people who weren't here, or just to get you back in the frame of mind of what we're looking for, talking about our parent function of f of x equals x squared, which is forming a parabola. And the parabola looks something like this. Very rough sketch. And so what we're doing now is we're taking a value of c and we're adding it onto the end of this quadratic equation. And we're asked to write 4 function rules that are in the same family. As in, if c was equal to 0, we said x squared plus 0, then the simplified version of that would be x squared. So this is asking us to give 4 more function rules that are in the same family. As in, if you took x squared for each of these and changed the value of the c. So if we added, say we added 1. This would still be in the same family of f of x equals x squared, but we're just adding 1 to it. And then what if this one said plus 5? What if this one said plus, I don't know, 6? And what if this one said plus 10? And take a minute and graph these on your calculator so that you can see what happens to them. Because we're trying to see how C affects the original graph. So I'll give you a second to graph these on your calculator. Okay, so this is the graph of y equals x squared, which is the original one. Okay, and this is a very poorly drawn picture of it as well. So I just wanted to show that when you graph these on your calculator, when you put y equals x squared plus 5 and x squared plus 6 and x squared plus 10, what happens to it is if you keep the y equals x squared in y1 and you put the other ones in y2 and y3 and y4, you see that the graph for y equals x squared plus 1 is shifted up 1 place on the y-axis. And if you did plus 5, it should have shifted up to 5 on the y-axis. And of course 6 would shift up to 6, and 10 would shift up to 10. So you can see it's the same graph, just being adjusted to whatever value your c is when it's greater than 0. So the next question asks about other values of c. How are the graphs with c is greater than 0 different from graphs with c is less than 0? So if we took this equation and instead of a plus 10 we did minus 10. Okay, what if we did minus 10? And if you graph this on your calculator, you'll see that this is the same graph. And instead of going up 10, it's going to be shifted down 10. I'm sorry that my graph stopped at -3. But you can see that it shifts down to crossing the y-axis at -10. And so what if instead of -10 it said -1? So it used to be here, crossing the y-axis at 0, 0, and now it's going to be shifted down 1, crossing the y-axis at -1. So what happens to the graphs when other values of c? How are they different from graphs? Different from graphs when c is less than 0. So when they're less than 0, then they shift down the y-axis. And when they are greater than 0, like these examples we did here, they shift up. So it's the same graph. I don't want you to think it's getting smaller. Your screen on your calculator may just show this tail end of it right here. Whoops. No, it may just show like this part right here of the window. Maybe all you're looking at, and you might be thinking, oh, well, that's made it smaller. It's just that your window needs to be adjusted, okay, because it's the whole thing being moved up. And what key feature does the value of C represent? So C represents the place where it crosses the y-axis, and a fancy word for that might be the y-intercept. Okay.